Okay, hello everyone. How are you all? So, so we are going to see next chapter, that is error analysis. So our purpose is today to understand error analysis. Okay. Again, very important chapter from NEET and JEE point of view. So error analysis. Let's understand what the topic is about. So we know that whenever we are going to do some calculation, that is what we do in physics, measurement, right? So whenever we are measuring some parameters, no, there would be some error in that measurement always. We cannot eliminate the error completely. So whatever measurement you do, there must be some error into that measurement. Okay. So for example, suppose we are going to measure a parameter, that is A. A is given as 3. Its value comes out to be 3 centimeter. Okay. So till now we were writing it any physical quantity, A equals to 3 centimeter, like that simply we were dealing with. Now if you want to account for the error also, so what we will do, we will write down with the symbol plus minus. So this plus minus represents what? Error. Let's say error is of 0.3. That is how we write a quantity with error. So A equals to 3 plus minus 0.3. So if I talk about this A, this value is absolute value of A. Absolute value of A, 3. This plus minus part would tell us absolute error. This part would tell about absolute error in A. Okay. So it can be written as, this is A, plus minus error value is written as delta A. So A is the absolute value, delta A is absolute error. So if I talk about delta A by A, it is called relative error. And similarly, if you multiply by 100, delta A by A into 100, this is called percentage error. Okay. So as example, we can take this one only. So 3 is our absolute value, 0.3 is our absolute error. If I talk about relative error, how much? So relative error would be 0.3 by 3, that is 0.1. And if I talk about percentage error, so multiplied by 100, that is 10%. Okay. That is how we write a quantity with error. Now we'll come back to this part later, but before that we have one thing to discuss. Suppose you are doing an experiment. You are doing an experiment and the data that you are getting is A1, A2, A3 till N. So n number of times you are repeating the same experiment and the data you are getting A1, A2, A3 dot 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 An. So these are the values that you are getting. So if I talk about what is my value, how much my answer, so I would take the mean of the all values. So A1 plus A2 plus dot 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 An divided by total number N. So that is my mean value. Okay. On this experiment basis also questions are asked. So this part should also be clear. So that is our value, A mean. If I talk about what is my error in the first calculation, delta A1, error in first calculation. So error in first calculation would be A mean minus A1 mod value, because it will take the positive values. Similarly, if I talk about delta A2, so mean value minus A2 mod. So if I talk about error in the nth value, so it would be mean value minus nth value of the experiment. Got it? This is my value, these are the errors in respective values. So if I talk about what is my error, so delta A but mean will take. So my error in the answer would be how much? Delta A1 plus delta A2 plus dot 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 delta An divided by total number N. So now if I want to write the answer of my experiment, so A mean plus minus delta A mean. Okay. So in this format, now we can write down the relative error as well as percentage error also. Okay, clear? Moving on to the next part. So now we have seen that if quantity A is there given, it is written as 3 plus minus 0.3 means 3 is the value of the quantity, 0.3 is the absolute error in that quantity. Similarly, if I talk about B, let's say it is 4 plus or minus 0.4. Okay. Now we are going to see addition and subtraction. Addition and subtraction. How to do addition and subtraction with errors? Okay, this is called propagation of errors. If you are doing one experiment, if you are calculating any value A with some error, and another again you are calculating some value B with some error, and now our answer is going to be addition of both A and B. So obviously there must be some error in the answer also, and that error we are going to see here. So for addition as well as subtraction, both what we do, absolute errors are added. Okay, keep it in mind, important point, added. Either addition you are doing or you are doing subtraction. In both of the cases, what you have to do, absolute errors are going to be added only, no subtraction, only added. Okay, so for example, if I want to do A plus B here, so it would be how much? 7 plus minus 0.7. If I want to do the subtraction here, let's say B minus A I want to calculate. So B minus A is how much? B minus A values 4 minus 3, that is 1, and error how much? Added 0.7 only. Absolute errors are added. So while addition or subtraction, you have to take care of absolute errors and you have to add them. Clear? So we can add two quantities, subtract two quantities easily. Now let's see for multiplication and division. Same thing for multiplication and division. Let's say again A quantity is 2 plus minus 0.2, B is 4 plus minus 0.4. Okay. So for multiplication and division, so what you have to remember for multiplication and division, relative errors are added, not absolute but relative errors. Okay, so when you add relative errors, what it would give you? It would give you the relative error only. So suppose I want to multiply these two, so I will write that product equals to AB. Okay, so product equals to AB, that's I'm writing. So this is my equation. Here important point, because from here we will learn a lot of things, that any relation is given, we can simply write down its error relation. So here relation is P equals to AB, product. So if I talk about relative errors are added, relative error would be delta A by A, and relative error in B, delta B by B, and simply addition, relative errors are added. After adding, what it would give? It would basically give relative error in P, so delta P by P. So delta P by P, delta A how much? 0.2 by 2 plus delta B 0.4 by 4. So calculation I've made simple only. So 0.1, 0.1, it would be how much? 0.2. That is relative error, delta P by P. Clear? So if you want to write down the absolute error, so 0.2 multiplied by the product. So 0.2 multiplied by product is how much? 8. So 1.6. So if you want to write down the answer would be how much? Product value would be 1.6 plus minus, sorry, product is how much? 8 plus or minus 1.6, and relative error 0.2, percentage error 20%. Clear? So product also clear. Now simply if you want to divide two quantities, let's say A equals to 3 plus minus 0.3 and B equals to 6 plus minus 0.6. So if you want to write out the division, B over A. So this is our first relation, division. From this relation, what we'll write? Error relation. So delta D by D equals to error in B how much? Delta B by B. Error in A how much? Delta A by A, and added. In either product or division, relative errors are added. So delta B by B how much? Delta B by B 0.1 plus delta A by A 0.1, that would be delta D by D. So delta D how much? 0.2 into D. D is what? D is how much? B by A. So D value would be 2. So D multiplied here 2 0, so 0.4. So if you want to write down the division, answer would be how much? Actual value 2, error how much? 0.4. That is delta D. Okay. So that is how we calculate error in products division as well as addition and subtraction. Now we are going to generalize this formula. Suppose generalizing this formula is P is given as A power X, B power Y upon C power Z. This is the relation multiplied with some power also. Now I want to write down the error relation. So here relative error in P should be equals to coefficient. Power is there, no power. So power would become coefficient. And important thing is that you have to make sure all the powers are positive. Otherwise error would be subtracted. No, if power is negative. But error is not actually subtracted. It always adds up. Okay. So you have to make sure that X, Y, Z, these powers are what? Positive. If it is negative, in denominator take it upward. If it is negative upward, take it downward. Basically you have to make it positive. So error relation would be, this power would become coefficient. So X multiplied by delta A by A plus Y multiplied by delta B by B plus Z multiplied by delta C by C. So this is the error relation. Error as percentage. So error as percentage is a particular type of question where we have to calculate percentage change, but using the method of error. Okay, we have to calculate percentage change using the method of error. For example, just suppose that kinetic energy is given as P square by 2m. This is the equation we know. Okay, kinetic energy P square by 2m. So the question is saying that error in momentum is 3%. Okay, error in momentum is how much? 3%. Then we have to find the error in kinetic energy. Clear? Error in momentum 3%. So error in kinetic energy. Important point. This same question can also be rephrased as a percentage problem itself without error. The question can be rephrased like this one. Momentum increases by 3%. What is the increase in kinetic energy? Or momentum decreases by 3%. What is the percentage decrease in kinetic energy? Or third one here itself, error in momentum is 3%. So percentage error in kinetic energy. So all these three type of problems have the same approach. So relation K is proportional to P square. So we can write down delta K by K is how much? Equality will be added, 2 multiplied here, it would be delta P by P. Okay, that is the relation of momentum, error relation. Now momentum, these are the relative, which will multiply 100 both sides. So it would become what? Percentage. So 2 into delta P by P into 100 is given 3%. So multiplied by 3, that is 6%. It is percentage error in kinetic energy. So percentage error in kinetic energy, how much? 6%. Okay. Same thing. Resistance proportional to L square for stretching out the wire. So when you are stretching the wire, resistance is directly proportional to length square. So again question is length increased by 2%. Length increased by how much? 2%. Then what is the percentage increment in resistance? Clear? So again R is proportional to L square. We'll write down, this is the, see, whenever small percentages are given, small. So percentages are small, so we can talk about it as error. Okay. Errors are always like small errors only, no, like not like blunders, small errors. So length increased by how much? 2%. Or we can say that the error in length is how much? 2%. So we have to find the error in resistance. Got it? Same error problem, percentage problem for small values, same. So if you write down the error relation delta R by R equals to how much? Proportionality, leave it. 2 times delta L by L multiplied by 100 both sides. So 100, 100. This is the percentage error in length, and percentage increase in length how much? 2%. So answer would be how much? 4%. So percentage change in resistance is how much? 4%. Clear? Anywhere if this relation is given, we can work out problems like this. Suppose a volume. So volume is given as 4 by 3 pi r cube. Okay. So the question is that radius, percentage error in radius is 2% or 1%. Percentage or calculation error. So error in radius how much? 1%. So what is the error in volume? So again error relation delta V by V equals to 4 by 3 pi is a constant, so leave it 3 into delta R by R into 100 into 100. So this is percentage in what? Volume. 3 times percentage in radius, that is 1. So answer is how much? 3% error in volume. Okay. Now one important point again, percentage problems itself, percentage problems. So percentage problems can be categorized into two parts, when the percent is given very small or when the percent is given very large percent. Okay, very small and large percent. So when the percentage is given very small, we can go through the error approach, like y is proportional to x power n. So percentage in y would become how much? N times percentage in x, as simple as that. When the error is very small, when the percentage is very small, then we can use this approach. Error method only we are going to use. Okay, so like few questions that we did know based on this approach only. Now we have to see the error percentage problem for the large percent. For example, kinetic energy equals to p square by 2m. Momentum increased by 100%. How much increment? 100%. So momentum increased by 100%. Then how we are going to solve? If you do the error method, so percentage in kinetic energy should be how much? 200%. But that is the wrong answer, because for the large percentage error method is not applicable. So what we will do, we will go with the factor method. Factor method. Okay, let's see what this factor method is. Momentum increased by how much? 100%. So initial momentum was p, increased means plus, 100% means 100 by 100 of the p. So it would become how much? 2p. Momentum becomes how much? 2 times. Kinetic energy is proportional to what? Momentum square. Momentum becomes 2 times, so kinetic energy would become how much times? 4 times. Okay, momentum 2 times, kinetic energy proportional to p square, so proportional, it is equals to 2 square. Kinetic energy would become how many times? 4 times. What is the factor here? 4. Factor minus 1 into 100 is the percent. Factor minus 1 into 100, 4 times. So how much percent? 300%. That is our actual answer. From the error method, how much we are getting? 200%. So not correct. Actual error is how much? 300%. Clear? Now, like this one, resistance proportional to L square, or length of the wire increased by, let's say, 10%. Length of the wire increased by how much? 10%. So what should be the percentage increase in resistance? Percentage increase in resistance they can ask. Now we can simply understand that resistance length is how much? 10%. By the way, error method for less than 5% only, that is good to for calculation. 5-6% around that, if the error is there, then we can take it, assume it to be what? Small value, and we can easily calculate by error method. But more than that, we have to apply which method? Factor method only. Okay, let's see. Resistance proportional to L square, length increased by 10%. So final length would become how much? L plus 10%, means 1 by 10 of L, that is 11L by 10. Resistance is proportional to what? L square. So resistance final would become how much? Square of the length, so 121 by 100 L R. So this is the final resistance. What is the factor? 121 by 100. Percentage is given by factor minus 1 into 100. Factor minus 1, 121 by 100 minus 1 into 100. That is how much? 21%. That is our answer. Clear? Easy one. Okay, so you have to be very careful about this error and percentage problems, especially in NEET. Still they are much more relevant. Okay, now one more question that can be connected with this projectile, x-axis, y-axis. Now we are throwing a particle with u speed. This is the initial point, this is the final point. At angle theta we are throwing it. The question will be like percentage change in velocity, percentage change in momentum, percentage change in kinetic energy between initial and final point, between this one and this one. What would be the percentage change? Okay, very simple. velocity here u, at this top point only horizontal component of velocity would remain, so that is u cos theta. How much it would become? Cos theta times, so factor is how much? Cos theta. Percentage is given by factor minus 1 into 100, done. Percentage change in velocity. Percentage change in momentum, so momentum is proportional to what? Velocity only, so same percentage change cos theta minus 1 into 100. Percentage change in kinetic energy, so percentage change in kinetic energy is proportional to what? Speed square. So velocity become, speed become how much time? Cos theta times, so kinetic energy would become how much? Cos square theta times of the initial value. Okay, velocity becomes cos theta times kinetic energy proportional to velocity square, so kinetic energy would become cos square theta time. What is the factor here? Cos square theta. Factor minus 1 into 100, cos square theta minus 1 into 100, that is our answer. Percentage, these are very important questions for NEET. Ratio of kinetic energy and all that they can ask initial and final by giving the value of theta. All of them would come out to be, I think, negative only, so you can understand that negative signs shows the decrement in the value. Okay, so this is about errors. Some more questions we will practice in the later lectures.